Welcome to Amara Rashid online math class. Today we want to continue with trigonometry, but this time around we want to discuss the inverse ratios of the three basic trigonometric ratios. Remember one of our videos the last time we started discussing that there are three fundamental or three basic trigonometric ratios. Sine is short, cosine, cos, and tangent, tan. These basic trigonometric ratios, they have respective inverse ratios. These inverse ratios are, we have what we call cosecant, we have what we call secant, and we have what we call cotangent. Alright. Now, before we continue, let us remind ourselves about inverse or reciprocals in fractions. In fractions, if you have 2 over 3, and someone asks you, what is the inverse of 2 over 3? You will say, the inverse of 2 over 3 is 3 over 2. And what if you are asked to give the inverse of 3 over 2? The inverse of 3 over 2 is as well as 2 over 3. Remember, the inverse of a fraction, the product of a fraction by its inverse will always give us 1. If we multiply these two, we shall get what? 1. So the inverse of 2 over 3 is 3 over 2. The inverse of 4 over 7 is 7 over 4. So likewise, in trigonometric ratios, the inverse of sine is cosecant. Likewise, the inverse of cosecant is sine. The inverse of cosine is secant. The inverse of secant is cosine. The inverse of tangent is cotangent. The inverse of cotangent is tangent. Now, this sine, its inverse is what? Cosecant. So likewise, the inverse of cosecant is sine. So we say cosecant is equal to 1 over sine. The inverse of cosecant is sine. So if the inverse of cosecant is sine, this means cosecant is equal to 1 over sine. But the short form of cosecant is cosec. And let us give it an angle like theta. If cosecant is 1 over sine, then cosec is 1 over sine. So cosec theta is 1 over sine theta. So what if we give this one a square? Cosec square theta. So here again we are going to give it a square. But squaring 1 will also give us 1. So 1 over sine square theta. Without a square, there must be no square. With a square, there must be a square because one term is equal to one term. Remember one of our videos where we discussed algebraic terms. Alright, so but if cosec square theta is 1 over sine square theta, and we know it fully that the inverse of cosecant is sine, the inverse of sine is cosecant, so we can deduce that sine square theta is also equal to 1 all over cosec square theta. Let us try to prove this one. If cosec square theta is 1 over sine square theta, why sine square theta is equal to 1 over this one? Let us see this proof here. Now we've already accepted that cosec square theta is 1 all over sine square theta. But why sine square theta is 1 over cosec square theta? Now what if we give this one, we give this a denominator of 1? Naturally the denominator is 1. So 1 multiplied by 1 we have 1. Multiplying these two is like putting them together. So we say cosec square theta sine square theta. But we want to make sine square theta the subject. So we divide both sides by cosec square theta, cosec square theta. This goes with this. So we say sine square theta is equal to 1 all over cosec square theta. So this is telling me that if cosec square theta is 1 over sine square theta, then sine square theta is equal to 1 over cosec square theta. Alright, let us go to the next one. The next one says the inverse of cosine, which we usually call cos, is secant. The inverse of cosine is secant. Then conversely, we can say the inverse of secant is cosine. So we say this secant is equal to 1 all over cosine. But the short form of secant is sec. And let us decide to give it an angle. Let's say theta. So this is 1 all over. The short form of cosine is cos. So cos theta. So secant theta is 1 all over cosine theta. Sec theta is 1 over cos theta. So without a square, there is no square. So if we intend to give this one a square, so there must be a square. Why there must be a square? Because squaring both sides. One term equals to one term. The square of 1 is always 1. So the square of this one is cos square theta. I don't need to prove this one again because of course you saw what we did when we tried to prove this one. Alright, so if sec square theta is 1 over cos square theta, we can deduce that cos square theta is equal to 1 over sec square theta. Alright, the last one here, number 3, the inverse of tangent, we used to call tan, is cotangent. The inverse of cotangent is tangent. So we say tangent, or let's say cotangent is equal to 1 over tangent. But the short form for cotangent is cot. And let us decide to give it an angle. Let's say theta. So if cotangent is 1 over tangent, then cot, the short form for this one, is equal to 1 over the short form for this one, which is tan. So remember, no square, no square. So what if tan theta, yeah. So what if we intend to square both sides? The square of this one is cot square theta, which is equal to the square of this one. The square one, we have 1. The square of this one, we have tan square theta. So if at all cot square theta is 1 over tan square theta, therefore tan square theta is equal to 1 over cot square theta. So these are the 3 fundamental trigonometric ratios. So you have been seeing me saying what? If you square this, you get this one. Now, if you have sine theta, you want to square this. If you square sine theta, you are expecting what? Sine theta all square. But it's accepted that I'm accepted to say sine square theta. See? Sine theta all raised to the power 2 is acceptable to say what? Sine square theta. So thank you for watching. Don't forget to follow, share and like the video for more. Bye bye.